Welcome. In this session of our tutorials, we are going to look at this question from Advanced Level Pure Mathematics Paper 2, and it is from the Southwest Regional Mock of 2024. It was question 6, and in the Roman 1 part, we have the graph below is the curve of the numerical function f of x in the xy coordinate plane. So the first question A says state the domain of definition of f of x for 1 mark, and B says state the coordinates of the y-intercept for 1 mark. C, write the equation of the horizontal asymptote, also 1 mark, and D says draw the table of variation of f of x for 3 marks. And in Roman 2, we are asked to determine the coefficient of x to the 6th y cube in the expansion of x plus 2y to the power 9 for 4 marks. So this is another topic, binomial expansions. In Roman 1, to start with, we are going to first analyze the graph. It is very important. When you look at the graph, you would notice that there is a point of discontinuity on that graph. In fact, the vertical line x equals -1 is a vertical asymptote, because you can notice that the graph is avoiding that line. As you can see, as x values are approaching -1 from the left, the graph tends towards positive infinity. And as x values are approaching -1 from the right, the graph tends to negative infinity. So x equals -1 is a vertical asymptote on that graph, and hence it is a point of discontinuity and is going to play a role in the writing of the domain of definition of the function. Further on observing, we notice that as x values are tending to negative infinity, the y values are approaching this line, this horizontal line. And again, on this other side, as x values are approaching positive infinity, the y values are still approaching this line, the line y equals 1. And so the line y equals 1 would obviously be a horizontal asymptote. Further, we can also notice that to the left of -1, the graph in that region is increasing. It has a positive gradient, because if you draw a tangent to that curve at any point, the tangent will have a positive gradient. So the curve is increasing in that region. In the region to the right of the vertical asymptote x equals -1, we observe again that the graph is increasing. So the function is increasing in that region, because any tangent drawn on the curve at that region will have a positive gradient. So these are some of the characteristics or properties of the curve that we need to be aware of before we start answering the questions. So we move straight away to the A part. In the A part, we are asked to state the domain of definition of f of x. So generally, the domain of definition of f of x is supposed to be the set of real values that the function can take. And here it cannot take all real values, because there is a point of discontinuity at x equals -1. Hence, we are going to write the domain as all values of x belonging to the set of real numbers except a value, and that value is -1. So this is the domain of definition of the function f of x. In the B part, we are asked to state the coordinates of the y-intercept. The graph cuts the vertical axis, the y-axis, where y equals -1 and x equals 0. So the y-intercept is the point 0, -1. In the C part, we are asked to write the equation of the horizontal asymptote. Okay, as we already analyzed, we saw that as x values are tending towards positive infinity, y values are tending towards 1. And as x values tend to negative infinity, y values still tend to 1. And so horizontal asymptote is y equals 1. In the D part, we are asked to draw the table of variation. Now, to draw the table of variation, we need to have 3 rows. The first row contains x values, and these values are mainly those that occur at the boundaries of the domain, as well as any x coordinates of turning points, if any. But in this curve, we don't have turning points. The next row would bear the sign of f prime of x in the various regions. And then in the last row, we are going to have the monotonicity or the variation of the curve in the various regions. So for the boundaries of the domain, we have negative infinity. There is a vertical asymptote at -1, and there is another boundary at positive infinity. Now, there is a point of discontinuity at -1 where x is -1, so that corresponds to a vertical asymptote. The curve doesn't exist in that region. As we already saw, wherever you draw a tangent on the curve, it always has a positive gradient, and so the curve is always increasing on its domain. It means that in the region between -infinity and -1, f prime of x will be positive, and in the region between -1 and positive infinity, f prime would also be positive. Okay, in the last row, we are going to indicate the variation or the monotonicity of f of x. We already saw on the graph that as x tends to -infinity, f of x tends to 1, 1 being a horizontal asymptote. So since the graph is increasing in that region, it would be increasing from the neighborhood of 1 towards positive infinity to the left of the vertical asymptote at x equals -1. And to the right of x equals -1, the vertical asymptote, we saw that the graph increases from the neighborhood of -infinity towards the horizontal asymptote there at y equals 1. So the graph would be increasing from -infinity to the neighborhood of 1, which is the horizontal asymptote. And so this is the table of variation of f of x. In Roman 2, we are asked to determine the coefficient of x to the 6th y cubed in the expansion of x plus 2y to the power 9 for 4 marks. So Roman 2, we have the expansion x plus 2y to the power 9, and we are looking for the coefficient of x to the 6th y cubed. For the expansion a plus b to the power n, the general term tr plus 1 equals n combination r times the first term a to the power n minus r times the second term b to the r. And so tr plus 1 would be equal to, now n is 9, so we have 9 combination r. R is a natural number to be determined in this question, and a is x, so we have x to the power n, which is 9, minus r to be determined, and the second term is 2y, so b is 2y to the power r. And when we simplify further, we have 9 combination r dot x to the 9 minus r dot 2 to the r dot y to the r. Since 2y to the r is 2 to the r times y to the r. And from here, we have that 9 combination r dot this other term 2 to the r, which will constitute the coefficient of x to the 9 minus r dot y to the r. The question asks for the coefficient of x to the 6th y cubed. So this is identical to x to the 9 minus r, y to the r. So comparing the powers of x and y on the left hand side, we can already see that for y, 3 corresponds to r. So r equals 3. Or 6 corresponds to 9 minus r. And from there again, r would be 3. So r equals 3 in this question. From here, we go back to our statement that we had as the general term. We had that general term as tr plus 1. And since we have had r as 3, tr plus 1 becomes t3 plus 1, which is t4. So actually, the term we are dealing with, that we are seeking to find the coefficient, is the fourth term in that binomial expansion. So t4 should be equal to 9 combination 3. Now we're replacing r, which is 3, times 2 to the power 3 times x to the 9 minus 3. So r is 3. So x to the 9 minus 3 now is x to the 6th. And then y to the r, and r is 3. So this is the term in x to the 6th y cubed. And we are seeking to find the coefficient. So this expression here is the coefficient that we are looking for. So coefficient should be equal to 9 combination 3 times 2 to the 3rd, which is 8. Now, 9 combination 3 is 84, and we are multiplying by 8, and that gives us 672 as the coefficient of the term in x to the 6th y cubed. Thanks for watching. If you are new to the channel, please consider subscribing and activating the notification bell so that anytime we upload a video, you would get a signal and then watch. I wish you good luck in your GCE exams.